Namaste students. In the last class we have completed continuity. As I have already told you, from this class we are going to start with differentiability. So you know the weightage for differentiability, there will be one question for 1 marks, two questions for 2 marks, two questions for 3 marks and one 5 marks question. So 16 marks is the weightage given for differentiability, vast weightage. And you know, here you have got separate units. First subunit is chain rule, second subunit is implicit differentiation, third is derivative of inverse trigonometric functions by substitution, next is parametric differentiation, then you have logarithmic differentiation, then second order derivatives, then mean value theorems. There are around 7 subunits in this particular chapter. So from 7 subunits, the weightage is around 16 marks. One 1 mark question, two 2 marks question, two 3 marks questions and one 5 marks question. First of all, we need to understand the process of finding the derivative and what is differentiability and all. Let us understand it in a simple way. Let us consider the function y is equal to f of x. Let it be a continuous function. Let us consider when x changes to x plus delta x, y changes to y plus delta y. What is the delta x and delta y? They are the small changes in the value of x and y respectively. They are also called as increments. We also call it as increments. So how this equation becomes now? Y plus delta y is equal to f of x plus delta x. Call this as equation 2. What is delta y? You can write it as f of x plus delta x minus y. So what is delta y now? F of x plus delta x minus y. What is y? Y is nothing but f of x. So let us dividing both sides by delta x and taking limits as delta x tends to 0. What happens now? Limit as delta x tends to 0, you will be getting delta y by delta x is equal to limit as delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Now students, this delta x tends to 0. It approaches 0, not exactly 0. When limit delta x tends to 0, delta y by delta x exists. That is taken as dy by dx. This is taken as dy by dx. Suppose if you replace delta x by some letter h, limit as it tends to 0, f of x plus h minus f of x divided by h unit. So this dy by dx, limit as delta x tends to 0 and delta y by delta x, that is defined as dy by dx. You know, delta y by delta x is called as the increment ratio. We call it as the increment ratio. Change in y, that is delta y is change in y, delta x is change in x. When delta x is very small, when it approaches 0, that is defined as dy by dx, that is taken as limit as h tends to 0. So how we have got h as 0? We have took delta x as h here, h tends to 0, f of x plus h minus f of x divided by h. That means this dy by dx means derivative of y with respect to x. In first case itself we have told derivative of y with respect to x. That means the rate at which the value of y changes with respect to x. You know, in y is equal to f of x, as x changes, y also changes. We have to determine the rate at which the value of y changes with respect to x. The rate at which y changes with respect to x is denoted by dy by dx. What do you mean by differentiation then? Differentiation means the rate of change of y with respect to x. The process of finding the derivative of a function is called as the differentiation. So derivative means dy by dx. Derivative means the rate of change of y with respect to x. Rate of change of dependent variable with respect to independent variable. The process of finding the derivative of a function is called as the differentiation. The property possessed by a function is called as the differentiability. That's what you need to remember. This is the basic definition of the differentiation. Last year you have solved problems on how to derive a function using first principles. You have derived the derivative of sin x, cos x, so on, and it was asked for 3 marks in the first PUC. This formula, we have used this formula. This dy by dx, you know, this is also denoted by f dash of x. Last year we used to use f dash of x. Yes, dy by dx is also defined by f dash of x, and it is also denoted by dy, capital dy, or it is denoted by y1, or it is also denoted by y dash. These are the various symbols by which dy by dx can be derived. So all these carry the same meaning, that derivative of y with respect to x. What do you mean by derivative of y with respect to x? Derivative of y with respect to x means we determine the rate at which the value of y changes with respect to x. The process of finding the derivative of y with respect to x, that is, process of finding the derivative of a function is called as differentiation, and the property possessed by a function is called as the differentiability. That's what you need to remember here. So dy by dx is denoted by f dash of x, or d of y, or y1, or y dash. So it is also denoted like in other form, you know, f dash of x can also be defined. So in different way, so in the textbook it is, they have given it in a different way. So limit as x tends to c, f of x minus f of c divided by x minus c. This is also another way of expressing the derivative of a function, that is dy by dx. So it can be, if it is written like this, it can be written as f dash of c. F dash of c can be written as limit as x tends to c, f of x minus f of c divided by x minus c. So this is another way of expressing the derivative of a function. See here, in general, f dash of x is equal to, you have limit as h tends to 0, f of x plus h minus f of x divided by h. That's what you have. Understood? This is what you have. X plus h, if you take x plus h as some c, so then obviously you will be getting all those values. See, this is in terms of limits. We know when the limit of a function exists. Limit of a function is said to exist only when left hand limit is equal to right hand limit. Here also we have left hand derivative and right hand derivative. So left hand derivative is for h tends to 0 minus, then it becomes f of x minus h minus f of x divided by minus h. That is what is called as the left hand derivative. I think you have understood. Left hand derivative will be limit as h tends to 0 minus f of x minus h, it is minus f of x divided by minus h. That is called as the left hand derivative. What is right hand derivative then? So right hand derivative of f dash of x will be limit as h tends to 0 plus f of x plus h minus f of x divided by h only. So this derivative of a function exists only when left hand derivative is equal to right hand derivative. If left hand derivative and right hand derivative approaches the same value, then only the derivative exists. So limit as f dash of x is equal to r of f dash of x. That's one. So what happens now? Limit as h tends to 0 minus f of x minus h minus f of x divided by minus h. That's what the left derivative is. Right derivative is limit as h tends to 0 plus f of x plus h minus f of x divided by h. That's it. So this is the condition. So derivative exists only when left hand derivative is equal to right hand derivative. So remember students, so derivative, so first we have considered y is equal to f of x. When x changes to x plus delta x, y changes to y plus delta y. Y plus delta y is f of x plus delta x. When we take y to RHS, y is f of x. Delta y is f of x plus delta x minus f of x. when we divide both sides by delta x and take limits as delta x tends to 0, limit as delta x tends to 0, delta y by delta x, RHS limit as delta x tends to 0, f of x plus delta x minus f of x by delta x. If this limit exists when delta x approaches 0, then it is defined as dy by dx. RHS, when you take delta x as h, limit as h tends to 0, f of x plus h minus f of x by h. So this is taken as dy by dx. That means to say derivative of y with respect to x. So dy by dx actually denotes the rate of y with respect to x. So derivative, finding the derivative means determining the rate at which the value of y changes with respect to x. The process of finding the derivative of a function is called as differentiation. The property possessed by a function is called as the differentiability. So dy by dx is also denoted as f dash of x, dy, y1 and y dash. All these carry same meaning. So since it is in the form of limits, we say that f dash of x is equal to limit as h tends to 0, f of x plus h minus f of x by h exists only when left hand derivative is equal to right hand derivative. Left hand derivative is L into f dash of x, right hand derivative is r into f dash of x. L stands for left, r for right. Limit as h tends to 0 minus it is f of x minus h minus f of x by minus h. Right hand derivative is limit as h tends to 0 plus f of x plus h minus f of x divided by h. So this is what the actual meaning. This derivative is also referred to as f dash of c as limit as h tends to c f of x minus f of c divided by x minus. I think you have understood how to understand the concept of derivatives. Now, I have got an important theorem. The theorem is, if a function f is differentiable at a point c, then it is also continuous at that point. That's what the statement is. If a function f is differentiable at a point c, then it is also continuous at that point. So what is the basic property there? Let us understand that property. If a function f is differentiable at a point c, then it is also continuous. It is also continuous at that point. This is what we need to prove. If a function f of x is differentiable at a point c, then it is also continuous at that point. At that point means at c. This is what. So, every derivative function, every differentiable function should be continuous. If a function is continuous, then only it should be differentiable. Converse is not true. So let us consider f is differentiable at x is equal to c. What do you mean by this? You know that limit as x tends to c, f of x minus f of c divided by x minus c is equal to f dash of c. That exists. You know this. This is what data. Now, for x not equal to c, we have what we have? F of x minus f of c, that can be written as f of x minus f of c divided by x minus c into x minus c. I think you have understood how we can write this. F of x minus f of c we have considered, we have written the same thing. So we have written x minus c in the denominator, the same x minus c in the numerator. That's what we have done here. Now, take the limits. Limit as x tends to c, f of x minus f of c. Limit as x tends to c, f of x minus f of c divided by x minus c into x minus c. That's what we have taken. Now, apply the limits. Limit as x tends to c f of x minus limit as x tends to c f of c is equal to limit as x tends to c f of x minus f of c divided by x minus c. Limit as x tends to c x minus c. Now it remains as it is. Limit as x tends to c f of x. Suppose if you apply the limits also, it remains the same thing. X tends to c f of c, it is f of c only. Limit as x tends to c f of x minus f of c by x minus c. What is this? This is nothing but f dash of c into x tends to c, it is c minus c, 0. So limit as x tends to c f of x minus f of c is equal to 0. C minus c is 0, 0 multiplied by f dash of c is 0. So what is your conclusion? Limit as x tends to c f of x is equal to, you take f of c to RHS. From the derivative we have proved that limit as x tends to c f of x is equal to f of c. That means f is continuous. So that means using the definition of derivative of the function, we have proved that f is continuous. That means to say every differentiable function, if we say that a function is differentiable, it should be continuous. But converse need not be true. That means if a function is continuous, it need not be differentiable. It need not be differentiable also. Okay? But every differentiable function is continuous. It is continuous is like 10 standard. Differentiable is like 12 standard science. So if you are past 12 standard science means obviously you would have passed 10 standard. But every student has passed 10 standard need not take 12 standard science. I think you have understood this. So if you have passed 12 standard science means obviously you have passed 10 standard, because 10 standard is continuity, 12 standard is differentiation. If a function is differentiable, then it should be continuous. If you have passed 10 standard science means obviously you have passed 10 standard. Suppose if you have passed 10 standard, you need not take 12 standard science. You can move on to diploma, ITI, any other course. So if a function is continuous, it need not be differentiable. It may be or it may not be. But if you say that a function is differentiable, it should be continuous. I think you have understood this. Every differentiable function is continuous. If a function is differentiable, then it should be continuous. Suppose if a function is continuous, it need not be differentiable. It may be or it may not be. I think you have understood this important theorem. I will explain it once again. See here, if a function is differentiable at a point C, then it is also continuous at that point. Since it is given differentiable, we have taken limit as x tends to c f of x minus f of c by x minus c, f dash of c exists. Consider f of x minus f of c, multiply and divide it by x minus c. So take the limits on both sides. Here also I have taken limits. So this function is nothing but f dash of c, and if you apply limits here, c minus c 0. Left hand side, limit as x tends to c f of x minus f of c. RHS will be 0. LHS, limit as x tends to c f of x minus f of c 0. You take f of c to RHS. Limit as x tends to c f of x will be equal to f of c. So function f is said to be continuous. That means to say, if a function is differentiable, then obviously it is continuous. So converse is not true. If a function is continuous, it need not be differentiable. It may be or it may not be. So it need not be differentiable always. I think you have understood this. Further, you have learnt many formulae in differentiation in first PUC. Let us concentrate on those formulae once again. So, formula which we have studied: d by dx of constant is always 0. Derivative of constant is 0. d by dx of k into f of x, constant into function, constant into derivative of the function. That's what we have learned. Third, d by dx of u plus v, du by dx plus dv by dx. Derivative of sum of two functions is sum of the derivatives. Similarly, you have got d by dx of u minus v, that is du by dx minus dv by dx. That's what we have learned earlier. So difference of two functions, derivative of difference of two functions, difference of their derivatives. I think you have understood all these basic formulae. Derivative of constant, all this you have studied. And derivatives of uv, that is product rule. So it is also called as Leibniz rule. You have studied that. First function, derivative of the second. Second function and the derivative of first. We used to call it as uv dash plus vu dash. That's what the product of two functions is. Suppose if you have derivative of product of three functions uvw, is uv into dw by dx, uw into dv by dx, further vw into du by dx. This is the product of three functions uvw. Seventh, you know d by dx of u by v. This is called as quotient rule. v into du by dx minus u into dv by dx divided by v square. How we used to call? Denominator, derivative of numerator minus numerator, derivative of denominator by denominator the whole square. This is the formula quotient rule. This is the product rule or Leibniz rule. First function, derivative of second, plus second function, derivative of first. So quotient rule is denominator, derivative of numerator minus numerator, derivative of denominator by denominator the whole square. I think you know this formula. Then d by dx of x power n, you have studied n into x power n minus 1. So d by dx of root x is 1 by 2 root x. I have studied this. Further, d by dx of 1 by x is minus 1 by x square. All this formula you have studied. D by dx of x power n, n into x power n minus 1, d by dx of root x is 1 by 2 root x, d by dx of 1 by x is minus 1 by x square. So I think you know all these basic formulae. You have studied all these in detail in the basic earlier classes. So these are the basic functions we need to remember. Now d by dx of sin x. d by dx of sin x will be cos x. So similarly, d by dx of sin ax. So the multiple angle which is a cos ax. You know this. So d by dx of sin x is cos x. D by dx of sin ax will be a cos ax. Similarly, you have d by dx of cos x. It is minus sin x. Similarly, here d by dx of cos ax. It is minus sin ax. Minus a sin ax is the formula. Suppose d by dx of tan x. d by dx of tan x is secant square x. And if you want d by dx of tan ax, that is multiple angle, it is a secant square ax. This is what tan x is. You want d by dx of cot x minus cosecant squared x. So d by dx of cot ax will be minus a cosecant squared ax. That is the formula we have. And d by dx of secant x, which is secant x into tan x. That's what the formula is. D by dx of, if you want it for multiple angle, secant ax, a secant ax into tan ax. That is the formula. Then d by dx of cosec x will be minus cosec x into cot x. If you want d by dx of cosec ax minus a cosec ax into cot ax. This is the formula. So 6 trigonometric functions. D by dx of sin x is cos x, d by dx of cos x is minus sin x, d by dx of tan x is secant squared x, d by dx of cot x is minus cosec squared x, d by dx of secant x is secant x into tan x, d by dx of cosec x is minus cosec x into cot x. Similarly, for multiple angles, d by dx of sin ax is a cos ax, d by dx of cos ax is minus a sin ax, d by dx of tan ax is a secant squared ax, d by dx of cot ax is minus a cosecant squared ax, d by dx of secant ax is a secant ax into tan ax, d by dx of cosec ax is minus a cosec ax into cot ax. That's what the formula you have. D by dx of exponential function e power x is e power x. Suppose if you want d by dx of e power ax, it is a into e power ax. You want d by dx of a power x, it is a power x into log a to base e. Suppose if you want d by dx of log x to base e, it is 1 by x. Suppose if you want d by dx of log x to base a, it is 1 by x into log a to base e. So this is what the formula we have. You need to know all these basic formula. So at least this 27 formula you need to remember. If you remember these formula, it will be very easy for us to solve the problems. So please concentrate on all these formulae. They are very, very important. So to start with, basic 10 formulae we have. Derivative of constant is 0. Derivative of k into f of x is k into derivative of f of x. Derivative of u plus v du by dx plus dv by dx. Derivative of u minus v du by dx minus dv by dx. Derivative of uv, very, very important. It is called as product rule or Leibniz rule. First function derivative of second plus second function derivative of first. U into dv by dx plus v into du by dx, or uv dash plus v into u dash. Derivative of product of three functions, it is uv into derivative of w, uw into derivative of v, vw into derivative of u. Each function you have to differentiate once, keeping other two outside. This is another important d by dx of u by v, quotient rule. So the numerator by denominator, denominator derivative of numerator minus numerator derivative of denominator by denominator the whole square. That is v into du by dx minus u into dv by dx divided by v square. You know d by dx of x power n is n into x power n minus 1. Derivative of root x 1 by 2 root x. Derivative of 1 by x minus 1 by x square. Similarly, 6 trigonometric function. For sin x it is cos x. For cos x minus sin x. For tan x secant squared x. Cot x minus cosec squared x. Secant x into tan x. For derivative of cosec x minus cosec x into cot x. Similarly, for multiple angles, sin ax, a cos ax, derivative of cos ax minus a sin ax, derivative of tan ax, a secant squared ax, derivative of cot ax minus cosecant squared ax, derivative of secant ax, a secant ax into tan ax, derivative of cosec ax minus cosec ax into cot ax, and we have exponential functions and logarithmic functions. Derivative of e power x, derivative of e power ax, a into e power ax, derivative of a power x into log a to base e, derivative of log x to base e 1 by x, derivative of log x to base a 1 by x into log a to base e. These are the formulae which you need to remember. At least 27 formulae you need to remember. So if you remember all these formulae, we can start with the problems. By next class, you need to write all these formulae at least thrice, and not mere writing. You need to learn. You please learn all these formulae, without which we cannot solve the problems. Because next class I am going to solve few basics problems on differentiation. Basic problems which you have studied in first PUC. Then I move on to the second PUC, wherein we are going to solve problems on chain rule. So before moving on to chain rule, it is very, very important to know how to solve the basic problems. Probably 6 months ago you have solved these problems. that is in for first PUC examination. By this time you would have forgot all those problems, application of formula and all. So we will have a fast recap of whatever you have studied in the first PUC. So before that you need to learn all these formulae, learn them. Then in the next class we are going to solve problems on differentiation, basic formula, first PUC problems. And then in the for further classes we are going to solve problems on childhood. So that's all for the day. Please learn these formulae for the next class. Please be prepared, and whenever we ask you the formula, you should be in a position to answer those formulae. Okay, that's all for the day. Thank you.